Alright, hello everybody. So by now you should already be in your seats, and hopefully you started on your do now. But you're going to have about 4 minutes to work through these 3 questions for your do now. Again, it's going to be 4 minutes for these 3 questions, silent and solo. The timer will start, and go ahead and pause the video here. Alright, now that we brought it back together, quickly going over this do now, I want to go over number 1, and then we're going to go over 2a. Number 1 is simply asking us to graph the equation 3y minus 2x is equal to negative 12. Well, because it's currently in standard form, I don't have a lot of useful pieces for me when actually trying to graph this. I can find the x and y intercept pretty easily. Remember that we would set each of these to 0 and solve for the other when we're looking for those intercepts. But what's going to be easier for us is actually just going to be to rewrite this into our slope-intercept form. And we know how to do this. It's something that we've done before. So we have this lovely 3y minus 2x equal to a negative 12. And we're going to be adding 2x to both sides. And so I'm going to be left with 3y, which is equal to 2x minus 12. And from here, again, we want to multiply by a reciprocal. So we're going to multiply both sides by 1/3. And remember to make sure that we're good with our parentheses so that we know that we actually have to distribute this in. And so I'm going to be left with y equal to 2 over 3x minus. And then 1/3 times 12, luckily that works out really nicely. It's just going to be minus 4. So this is my equation. This is that same equation just quickly written in slope-intercept. And so what this is going to show me is that our slope, or our m value, is going to be 2 over 3. And that our b value, also known as our y-intercept, is going to be negative 4, which remember is, when we write it as a point, is going to be 0, negative 4. So if we're actually looking to graph this, I'm going to come over here, I'm going to find my y-intercept. It's going to be right here. From here, I'm going to use my slope. Remember that my slope is my rise over my run, and they're both positive, which means I'm moving up and to the right when I'm counting these out. So I'm going to go up 2 and over to the 3, and that'll be another point there. I'm going to go up 2 and over 3, and there will be another point right there. And I can actually fit one more, so I'm going to go up 2 and over 3 one more time. And apologies if this is not going to be the nicest line in the world, but it's going to look a little something like that, minus all of the curves. And that's going to be our lovely line. So looking at number 2, a taxi ride in Detroit costs $11 for 2 miles and $18 for 4 miles. Let x represent the number of miles and y be the total fare. So first things first, they already defined our variables here, where x is the number of miles and y is the total fare, which is awesome because it means that we don't have to worry about doing it. And then they also give us some other information here. We have this 11 and 2 and this 18 and 4, and we're going to use these to form our coordinate points. So I know that we're going to have 2, 11. We're also going to have 4, 18. And then this is going to be my x1. This will be y1. This is going to be x2. This will be y2, because 2a says to write an equation that represents the total cost of a taxi ride. Well, I have a few different ways I can do this. I can either find the y-intercept and use a slope. I can use a slope in one of my points. But either way, I'm going to need slope. And so I've already labeled all my points out. I know all of my variables. So I know that m is going to be equal. That should be a 2. We're going to have 18 minus 11 over 4 minus 2. This is going to give us 7 over 2. Now, as we know, there's unfortunately no nice way to reduce this. This is just going to have to stay as is. But now we have a couple options. Now, I'm not given exactly what my y-intercept is, so I can't put this into slope-intercept form. But I do have 2 points, so I'm going to simply use point-slope form. So once I get here, I know that I can use either of these points. This is already labeled x1 and y1, which works for the purposes of this equation. So I'm going to have that y minus 11 is equal to 7 over 2 times the quantity of x minus 2. And that's it. That's my equation. We don't have to go any further than that. In part B, you would end up substituting 7 in for x. And I'm not going to show the work, but you should get 2850 for a 7-mile ride. And if you do want to see that, it is on the monitoring key that can be shown on the dock cam, but this is the value that you should be ending up with. Take a second and have this down. If you need to pause, you can. But from here, we're going to be moving to notes, so go ahead and make sure that once you have this, all notebooks are out. All right, so moving down to our notes here. For example 1, we're actually being asked to graph 2 equations here. We want to graph 4x minus 3y equal to 6, and 8x minus 6y is equal to 12. Now find space in your notebook. Make sure today's date is at the top. Today is going to be the 2nd. And take 3 minutes. Graph both of these in your notebook. You can do them side by side if that helps you see it. But then we're going to answer some questions about these graphs. Again, take those 3 minutes. Go ahead and pause the video here and begin. All right, now that we've come back together, in order to graph these, the first things I need to do, just as I did up in Arduino, is I'm going to rewrite these into slope-intercept form. Now really quick, this is going to give me negative 3y equal to negative 4x plus 6. So I'm going to have that y is equal to a positive 4 over 3, because remember, a negative divided by a negative is going to be a positive x. And then a positive 6 divided by negative 3, negative 2. And so from here, again, just like I did up above, I'm going to find that y-intercept, that lovely negative 2 point here. I'm going to use a slope to find all my other points. I'm going to go up 4, 1, 2, 3, and 4, over 3, 1, 2, and 3. And then once again, 1, 2, 3, and 4, and then 1, 2, and 3, and I got another one there. And once I have those 3 points, again, apologies, not going to be the best line, but we know it's going to look something like that. And then jumping over here to number 2, for 8x minus 6y equal to 12, I have to do that same process. So I'm going to have that negative 6y is equal to negative 8x plus 12. I'm going to multiply both sides by a negative 1/6, or divide both sides by negative 6, whatever is easier for you to conceptualize. We're going to have that y is equal to a positive, again, because we have a negative divided by a negative, so it's going to be a positive 8 over 6x. And then 12 divided by negative 6 is going to be a minus 2. So once again, our y-intercept is going to be right down here. It's going to be 0, negative 2. And now I need to go up 8 and over 6. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, and 6. And it's going to go there. And so with those 2 points, I'm going to make my line. And so we should have something that looks like this. Now by now, after you've graphed them, you should have hopefully noticed some interesting things going on here. I want you to turn and talk, take all of 15 seconds with someone near you. What do you notice about both graphs and their equations? Ready, set, go. All right, it's going to be about 5 more seconds to turn and talk. All right, so hopefully you're noticing that our lines, where they drawn a little bit neater, are going to be identical. Our lines are going to be identical. And if we look at our actual equations, especially this one here on the right, we can see that this slope is definitely reducible. So I'm actually going to do that. And so when I reduce that slope, that's actually going to bring it down, because I can divide both top and bottom by 2. So I'm going to end up with y equals 4 over 3x minus 2, which again is identical to the one we have over here. And so if you saw that they were identical, and if you and your partners looked back at our standard forms and saw these here, you might have said, oh, hey, wait a second. I see that this 4x here is half of this 8x. this negative 3y is half of this negative 6y, and this positive 6 is half of this positive 12. And so what that really means is that we've taken this equation here, multiplied it by 2 on both sides, and ended up with what we have here. And so what that really means is that if we take our equations in standard form and we multiply both sides by a constant, we're actually going to end up with an equation or a graph that's going to be equivalent. And we've really just seen that and proven that here. Because when we were to simplify or graph or find solutions or points or anything like that, we're going to find that they're always going to be identical. So again, what do we notice about these graphs and their equations? We notice that they are the same. These two here, although they look different to begin with, are identical. And so what do we notice about the point 6, 6, right? Because that point shows up here, and it shows up here. And so it should follow suit that if they're going to be the same equations, then it would make sense that 6, 6 should show up on both graphs, because they are both solutions. Apologies on my handwriting there. But again, what we notice about the point 6, 6 is they're both solutions. So 6, 6 is a solution for both of these equations here. And so if we wanted to prove this algebraically, how exactly could we do that? Well, if you're sitting there and hopefully someone had mentioned, well, we can simply plug it in, that's exactly what we would do. You could plug 6 in for both x and y on both of these, and you should, on both sides, end up with 6 equals 6, and then over here, 12 equals 12. So take a second, make sure you have this down, and then we're going to do a quick little mini stamp, but go ahead and pause if you need to, because we just went over a lot. All right, so underneath this, we really want to make that stamp. You know, make it special, start, whatever you have to do to really make this stand out. And we're going to stamp here that multiplying an equation by a constant on both sides. Remember, whatever we have to do to one, we have to do to the other. Does, you know, we're going to make this really nice and bold. Does not change the equation. So again, we have here that multiplying an equation by a constant on both sides does not change the, oh, I forgot the word equation. Equation. And again, we've just seen that. And so today we're going to look at a few more examples where we're finding that we can manipulate equations and we know what it's going to look like on both sides because we're simply multiplying by a constant. So make sure you have that down. Go ahead and pause the video again if you need to. All right, and now that you have that, we're going to go to problem set A. Problem set A has 3 questions. Question 3 has a few parts to it, but it should hopefully be pretty quick once you catch on exactly what's going on there. For these 3 questions, or these 3 sets of questions, I should say, take about 7 minutes. Let's work silent and solo on these 3, because then we can move into some partner work. But 7 minutes, silent and solo, for these 3 questions. Please begin. You can pause the video here. All right, so you have hopefully gone through these, put something down for hopefully all of them, But we're going to quickly rapid fire our way through these because, like I said, hopefully once you can kind of see what's going on, these tend to be pretty quick. So number one, which equation will have the same solution set as 2x minus 4y equal to 1? So we're given 4 options, and really what we're looking for here is we want to see which one of these is really the same thing as this, where both sides have been multiplied by a constant. So the way that we're going to look at this is we look at 6x is the first thing that I look at. So we have 2x and we're going to 6x. So I know that we're multiplying both sides by 3. So I should have a 6x, yep, because I multiplied by 3, and then multiplying this by 3 is going to be a negative 12y, which works. But then I remember I have to multiply this side by 3 as well. We haven't done that here. So I know that instantly this one's out. Looking at b, I have 4x. So I've gone from 2x to 4x. So I'm multiplying by 2. Then I have minus 4y. So I should have minus 8y. I don't. So again, this one's out. Moving down, I have 2x going to 10x. We're multiplying by 5. So I should have minus 20x, right? I don't. Again, we are out. So that really only leaves one option, but I still have to double check. So I have 2x going to 2x going to 8x. So I know that I'm multiplying both sides by 4. So then negative 4y times 4 is going to give me negative 16y. Perfect, check, that's what I want. And then my right-hand side, 1 multiplied by 4 is going to be 4. So perfect, this one checks out. And again, the reason we know that is because this is really 4 times 2x minus 4y equal to 1 times 4. Remember, we really just have said, hey, we're going to take a constant, in this case 4, and multiply it to both sides. And that's how we know this solution set is going to be the same, because these are in fact the same exact line. So moving to number 2, it's the same process. It's the same process that we have going on. We just have to make sure that we're paying attention to our negatives in this one, because if you aren't paying attention to your negatives, this one's actually going to get a little tricky. There is some harder answers thrown in there to purposely mislead you. So looking at this first one here, I'm going from negative 3x to negative 6x. Okay, so we're multiplying by 2. I have 2y, awesome, that checks out, equal to 2. Well, this should be equal to 2 if I'm multiplying both sides by 2. So I know that a is out. So we're going from a negative 3x to a negative 9, to a positive 9x. So it means I'm actually multiplying both sides by negative 3. And this is why we have to really make sure that we're watching our negatives. Because if I'm multiplying positive y times a negative 3, I should have a negative 3y. Perfect, awesome. And then if I multiply 2 by negative 3, I should have a negative 6. This is the one that's kind of thrown in here. This is sort of our red herring, or our bait, I'll call it. Because if you're not watching your negatives, there's a good chance you pick this one. And if you did, always remember that when we have a negative times a positive, it's going to be a negative. But because this is in a negative 6, we're actually going to cross this one out. And if we look at the one below it, we can see, hey, you know what? This one's exactly the same on the left-hand side, so I know they've still multiplied it by a negative 3, but then I have that negative 6. And because I have that negative 6, I know that it's in fact going to be C. Because again, this one here is going to be the same thing as though I had taken a negative 3 and multiplied it by both sides of my original equation. Oh, it would help if I actually wrote my original equation. So negative 3x plus y equal to 2 times a negative 3. All right, so moving on to 3. Again, these should be quick hits. Once you figure out what the first, or what one side is being multiplied by, you should hopefully be able to figure out that second side. So I'm going from 2x plus 3y to negative 4x minus 6y. So looking at this, I know that from 2x to negative 4y, I've gone and multiplied by negative 2. From positive 3y to negative 6y, again, I've multiplied by negative 2. So it stands to reason that I have to multiply this 7 here by negative 2. So I should have a negative 14. Moving down 1. My right-hand side's already filled in for me, so I know that in order to go from 7 to 28, I've multiplied by 4, which means I'm multiplying both sides by 4. This checks out on the 3y, because 3y times 4 is going to be 12y, and I know that 2x times 4 is going to give me 8x. So again, I need to do the both on the same side, or the same thing on both sides. And then moving down from 7 to 56 is going to be times 8. Again, that's going to check out over here on this 16x. I'm going from 2x to 16x, so I'm multiplying by 8. Awesome. And then that means that for that 3y, I'm going to have to multiply by 8 there as well. So I'm going to have 24y. So again, hopefully 3 were just some quick hits for you, going in there and really just filling in those values. Again, as soon as you kind of see what's going on one side, you know that it has to be happening on the other. And so you just check your coefficient, multiply it, and you're good to go. Again, take a second and get these down if you need to. If you had chosen B, make sure you're really highlighting that it should be C and making sure you're watching your negatives for number 2. But once we have this down, we're going to move on, but go ahead and pause the video if you need to. All right, so next you're going to find in your packet, it says example 2, it says we do. I believe in the packet when I printed it, it might actually be after your problem set B. You might have to search for it, but as soon as someone finds it, just let whoever's filling in know exactly where it is and let your classmates know. And then let's give everyone 30 seconds to make sure that we're on this page. Again, it says example 2, we do at the top. All right, so I'm going to give you a minute to read through this top piece here, to read through this top part, and then to start A. A is simply just asking you to write an equation of what's going on, specifically in standard form. Take 1 minute, read, annotate, and answer question A, and then we'll come back. Go ahead and pause the video. All right, so hopefully by now you've had some good annotations, and you've also written down exactly what's going on for A. So for the rest of this, and I'll be sure to put the answer here, but for the rest of this for right now, I want you to actually partner up with whoever's next to you. If you don't have someone directly next to you, find someone that's going to be close and partner with them. We should be staying in our seats for this. But go ahead and work on B and C with that partner. You're going to have 5 minutes to work through those. It's going to be really similar to what we were doing. Again, 5 minutes with that partner. Go ahead and start. All right, so we should all be back together now. Hopefully you made it through this, and hopefully this isn't something that's causing us too much trouble. I really want to go over A and B with you right now. So for A, for our equation, when we're reading through this, notice, we have some really nice useful information. We have $45 that we're going to use. We have $1 for a bag of cookies and $1.50 for a bag of veggies. Now, the one thing it doesn't do is it does not define our variables. So we need to make sure that we are actually defining our variables when we're writing this. So you could have had these switched, and that's totally okay. But we're going to have that x is equal to the number, I'm going to say of cookies. Specifically, it'll be bags of cookies, but for the sake of writing, it's going to be bags of cookies. And y is going to be my number of veggies. So using that, I know I need to use all $45. So I'm going to have x, because remember, we could write 1x, but it's not really necessary. So I'm going to have x plus 1.5 y is equal to 45. And again, that's really all I need to do for A. And looking down at B, it says that the local store you are counting on is no longer an option. Oh no. Since the owners will be on vacation, you're able to find another vendor, but they're more expensive. In fact, everything is twice as expensive. So a bag of cookies is now $2. A bag of vegetables is now $3. And if you want to be able to purchase the same amount of vegetables and cookies as you would have in the first store, how much money should we ask the treasurer for? Well, let's take a look back at our original equation. So our original equation that we made says, hey, we have this x plus 1.5y equal to 45. Really, that's $45, right? And we said, hey, everything over here is actually now twice as expensive. So what this is really saying is that you're taking this side and you're actually going to multiply it by 2. And remember, whatever I do to one side, I have to always do to the other. Which means that we're going to multiply this side by 2 as well. And so this new equation, even though it's going to be the same, because remember that's what we stamped in our notes, it'll be an equivalent expression, or an equivalent equation, it's going to look different. So we're going to have that 2x plus 3y is equal to 2 times 45 is going to be 90. And that makes sense, right? Because I have this lovely $2 here per bag of cookies, which checks out. And then I have this lovely 3, which is per bag of veggies, which also checks out. And so looking at my right-hand side, I have this 90. And so remember that this 45 right here was the amount that the treasurer had given us to use. And so if everything on my left have doubled, if all of my costs doubled, it's going to stand to reason that the amount that I need to ask my treasurer for will also double. So I'm going to have to ask my treasurer for $90 for shopping at this new store. And moving down to C really quick too, I don't even have to worry about what's going on my left-hand side, because I know that I'm multiplying my left-hand side by 5 times now. We're saying, hey, it's now 5 times as expensive, right? And so if we have this 45 value, we're actually taking this 45 value and we're going to do that same thing. We're going to multiply it by 5, and you should end up with 225, which means that we're going to actually have to ask our treasurer now for $225 instead of just $45. All right, take a second, make sure you have this. Perfect. Now, depending on the time that's left in class, to your teacher that's filling in, if they have more than 10 minutes, I would say like if they have 15 minutes, they can go ahead and start on problem 1 of problem set B. Work through problem 1, and again, it's really just problem 1 for about 5 minutes. We want to make sure that you guys have about 10 minutes left for your exit ticket. If you're already approaching that time, go right on down to that exit ticket right now. Your exit ticket is 2 questions. It's just 1 and 2. It's using everything that we did today. And again, you should have until the end of class to go ahead and complete this. As usual, there is homework attached. So there is homework going on. Make sure you read your directions carefully on your homework so that you know exactly why you have an equation bank and what is going on. But again, for now, you're going to work on your exit ticket, silent and solo, until the end of class. You can go ahead and end the video here.